Next is lattice enthalpy, and it is defined for the ionic compounds. Lattice enthalpy of an ionic compound is the enthalpy change which occurs when 1 mole of the ionic compound dissociates into its ions in the gaseous state. Example: solid sodium chloride dissociates to give sodium ions and chloride ions in the gaseous state, and the amount of energy required to do so is 788 kilojoules per mole of sodium chloride solid. Now, the experimental determination of the lattice enthalpy is impossible, so the application of Hess law is used. Here, Hess law of constant heat summation is used to determine the lattice enthalpy by an enthalpy diagram which we call the Born-Haber's cycle. Here, the Born-Haber cycle for sodium chloride is shown in the diagram. The formation of sodium chloride involves certain steps. First, the sodium metal taken is sublimed to form the gaseous sodium atoms. This step requires 108.4 kilojoules per mole of energy. After the formation of the sodium gaseous atoms, the ionization of the sodium gaseous atoms takes place, where 496 kilojoules per mole of energy is required. By the absorption of this much energy, the sodium atoms get converted into sodium ions. Then the next step involves the dissociation of the chlorine gas. Now, since for the formation of sodium chloride, 1 atom of sodium reacts with 1 atom of chlorine, but chlorine is a diatomic gas. So, we require only half mole of chlorine gas to form the required number of chlorine atoms. And therefore, the bond dissociation energy gets halved. So, by the involvement of half of the bond dissociation energy, the half mole of chlorine gas converts into the chlorine gaseous atoms. Then the fourth step involves the formation of chloride ion by the absorption or uptake of 1 electron by the chlorine atoms. This involves the electron gain enthalpy, and it is the amount of energy released when an electron is added into the isolated gaseous atom. Here, the electron gain enthalpy for chlorine is minus 348.6 kilojoules per mole. Now, the last step is the combination or coming together of the sodium ions and the chloride ions to form solid sodium chloride crystal. So, in all we can say that this is the first step, this is the second step, this one is the third step, this one is the fourth step, and this one is the fifth step. If we sum all these 5 steps and we equate it with the heat of formation of sodium chloride from the element sodium and chlorine gas, then we find that the sum of all these steps and the heat of formation of sodium chloride both are equal. So, by applying the Hess law, we can calculate the lattice enthalpy as 1, 2, 3 and 4 steps energies we have added, and this is the fifth step energy, that is the enthalpy change, and we will equate these five with this lattice enthalpy, with this heat of formation of sodium chloride. Now this gives us 788 kilojoules per mole of lattice enthalpy. Similarly, we can calculate the enthalpy for the other ionic compounds also. Next topic is the enthalpy of solution. Enthalpy of solution is the enthalpy change when 1 mole of the substance is dissolved in a specified amount of the solvent. The enthalpy of the solution at infinite dilution is defined as the enthalpy change observed on dissolving the substance in an infinite amount of the solvent when the interaction between the ions or the solute molecules, they are negligible.